Alright, so in today's video we're going to be looking at section 10.1 concerning the ellipse. Ellipse is one of what are called the conic sections. And these are called a conic section for this reason. If we were to take two cones and stack them, here's like an ice cream cone, and then put another one below it in the opposite direction. Right, those two cones stacked. As we slice this cone by a plane, think of a sheet of paper slicing through the cone. The cross section that we create on the cone is what's called the conic section. And in particular, if we were to take a sheet of paper, slice through here, the cross section we would get would be this shape right here, which is an ellipse. Okay, so historically that's why they're called conic sections. Now, in terms of actually defining the conic section, we have a geometric definition. So we think of this as sort of a constructive definition of how you would actually create an ellipse. For example, if you wanted to cut an ellipse out of a sheet of plywood, this is how you would do it. You'd use this definition. An ellipse is the set of points xy, meaning points in a plane, such that the distance between each of two what are called focal points, 2xy, when added, is constant. In other words, if we have these 2 points, consider them to be focal points. We can orient them any way we want, so let's just lay them in this direction along the x-axis. Okay? And we'll put them such that they're centered on the origin. So this will be the y-axis halfway between those 2 points. And therefore, this is the point negative c0, and this is the point c0 for some arbitrary value of c. These are going to be our focal points. Out here will be an xy point. That's a point on the ellipse. And what will be true about that point is if we take this distance here from this focal point to that xy, and this distance here, the distance from this focal point to this xy, and we add those together, d1 plus d2 has to always be constant. In other words, if you were to put a thumbtack here and a thumbtack here and take a piece of string, tie it to each of the thumbtacks, and then take a pencil and pull that string taut, you'd hit this point. Now, as you keep the string taut and swing it around, you would be sketching out the shape of an ellipse. And what's true about this shape is that any point on this ellipse, so you're here now, that this distance plus this distance will still be the same constant value. Okay? All right, so that's our constructive definition of an ellipse. And now from this constructive definition, we can derive an algebraic form for the equation of an ellipse. And we start with this idea. d1 plus d2 is constant. All right? We're going to call the constant in this case 2a. So you could think about it this way. If your point xy was here, this distance and this distance would be the same. That would be a and a added together to make 2a. Okay? Now, how we find the distance between 2 points? We use the distance formula. And the distance formula says it's the difference in the x-coordinates squared plus the difference in the y-coordinates squared, all square rooted. X minus negative c squared plus y minus 0 squared, square rooted. And we add this distance over here as well. X minus c squared plus y minus 0 squared, square rooted. And that's 2a. Okay? Now, cleaning this up just a little bit underneath the square roots, we have x plus c being squared plus y squared. Here, x minus c being squared plus y squared equals 2a. And I need to solve this into a form that's easier to work with. Excuse me. So I need to get rid of those square roots. Now, remember, when you're solving an equation involving square roots, your first step is to isolate one of the square roots, and then once it's isolated, you can square both sides of the equation. So let's keep this square root on the left. Let's move this one over to the right by subtracting it. And now we're going to square both sides. When I square the left, that simply removes the square root. When I square the right, this is going to multiply itself. This times this twice. And then this thing squared. So I still have a square root. Now, notice that you have a y squared here and a y squared here. You can cancel those from both sides. I want to solve this now. So let's get this square root isolated. Let's go ahead and think about how we're going to square both sides again. So let's move this 4a squared over to the left. Let's move this x minus c squared over. And then I have this left on the right. All right. So let's see what we can simplify here. Well, x plus c squared is x squared plus 2xc plus c squared. X minus c squared is going to be subtracted, so that's a minus of x squared minus a negative 2xc, so plus 2xc, and then minus a c squared. X squared minus x squared cancels. C squared minus c squared cancels. We have 2xc plus 2xc, which is 4xc minus 4a squared equals a minus 4a x minus c squared plus y squared being square rooted. Now, let's think about how we can get rid of this. Simply divide by a negative 4a. So that this divided by a negative 4a is going to leave an a. This divided by a negative 4a is going to leave a minus xc over a. And we've got this square root isolated. Now I can square both sides. On the right side, a squared minus this times this twice. Well, this times this, the a's are going to cancel. Okay, so you're going to get minus xc twice, and then you're going to get this squared. All right, we need another sheet of paper. All right. So, a squared minus 2xc plus x squared c squared over a squared. Square this out. X squared minus 2xc plus c squared plus y squared. Minus 2xc here, minus 2xc here. Those can cancel from both sides. Okay? All right. Now, let's move everything over join together. And let's move everything over to the right here. Except for the a squared. I'll leave the a squared where it is. So that means I'm just moving this term, I guess. We're subtracting this from both sides. Oh, and I've got this c squared. Let's subtract that from both sides. Okay. And so now, over on the left, I have a squared minus c squared. On the right, I've got this x squared minus x squared over times c squared over a squared. Let's get a common denominator of a squared on this. Okay, factor out the a squared, or the x squared from this. And now, as a final step, let's divide by a squared minus c squared. Those cancel, leaving 1. These cancel here, leaving x squared over a squared. And these over here, that's y squared over a squared minus c squared. And typically what we do is we say, let's replace a squared minus c squared with a simpler form. Call it b squared. And there you have the algebraic form, the equation, standard form of an ellipse. And specifically, this is the ellipse that we were working on from this diagram, meaning this is the ellipse that is centered at the origin and such that the focal points lie along the x-axis. Okay. All right. So this is a very straightforward formula for us. And here's the interesting thing to realize about this ellipse. If a squared and b squared are in fact the same value, then you could say there's a common value, call it r squared. If you multiplied both sides by r squared, then you'd have r squared equals x squared plus y squared, which is the standard form for the equation of a circle centered at the origin. And that's the case. What is happening is you're saying that the ellipse has devolved into a circle with these two focal points here, shrinking and dropping down to be the center point. So the two focal points coming together. In other words, the closer these two values in the denominators are to each other, the closer this shape of an ellipse is to being a circle. So as a and b become closer and closer in value, this ellipse gets rounder and rounder, approaching a circle. Okay? The bigger the difference between the value of a and b, the flatter the ellipse is. All right. So basically that's what we need to work with. There's just a couple of things to point out to you. The reason I can look at this and realize that the focal points lie along the x-axis is because the value of a would be larger than the value of b. So this is the case when a is bigger than b. That major axis is along the x-axis. If, on the other hand, b is larger than a, the major axis is along the y-axis, and the focal points would be along the y direction as well. So they'd be 0 plus or minus c. Okay? In other words, whatever variable has the larger of the denominators That's the variable that tells you in which direction the focal points lie. All right, let's try some of these exercises from the author's exercise set here. Starting with in problem number 6, the author asks you to determine whether this is an ellipse or not. He gives you 2x squared plus y is 4. This is not an ellipse. And the reason it's not an ellipse, the y is not being squared. The y has to be squared in that form. 8. 4x squared minus y squared is 4. This is not an ellipse. The reason this is not an ellipse is there's a minus in front of the y squared instead of a plus. 10. 4x squared minus 8x plus 9y squared minus 72y plus 112 equals 0. This is an ellipse. And the reason it is an ellipse is both the x and the y are squared, and they're being added to each other. They're both positive. That tells me this is an ellipse. Now, to get this ellipse to look into a standard form, what I would actually have to do is complete the square. And certainly you've seen completing the square somewhere in your past studies, and it may not have made very much sense. Typically, you see it when you're learning why the quadratic formula works. But it really doesn't make a lot of sense until you get into this type of work in math, where you can understand why completing the square is actually useful. In the process of completing the square, it's simply taking an equation and rewriting it so that you have terms simply squared. So let's take a look at this 4x squared minus 8x. I'm going to complete the square on that. And then you've got a 9y squared minus 72y. I'm going to complete the square on that. And then you've got this plus 112 equals 0. The way I complete the square is the following. I factor out whatever is in front of the x squared. I factor out whatever is in front of the y squared. And then I look at this and I say, okay, what would I add in the brackets here to turn this expression into a perfect square trinomial? And that is easy because the coefficient on the x squared is 1. All you have to do is take this number here, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. You square that, you get 1. I have to add a 1 there. Similarly over here, take the negative 8 divided by 2, you get negative 4. Square that, you get 16. Put a 16 here. Okay? Now, what's in the brackets here has x minus 1 quantity squared. What's in the brackets here? Y minus 4 quantity squared. Now, over here, I added a 1 in the brackets, which was multiplied by a 4. So I added 4 to this entire thing. I have to come up here and say, let's add 4 here as well. Over here, I added a 16 in the brackets. But that 16 is being multiplied by 9. So 9 times 16 is 144. I added 144 here. I have to add it there as well. Now, this 112, let's go ahead and subtract it. And so what you get on the right is 4 plus 144 minus 112. And that turns out to be 36. Now, when you look at this, 4, 9, 36, something strikes you. If you were to divide everything by 36, well, then you could get the 1 that you need on the one side of the equation, and these numbers will simplify nicely. 4 and 36 cancel. 9 and 36 cancel nicely, leaving a 4. And of course 36 over 36 is 1. And there's your standard form for the ellipse. The only difference between the standard form here and the standard form here is this one was centered at the origin. Here you've shifted the center. You've subtracted 1 from the x, you've subtracted 4 from the y. This is centered at 1, 4 instead of at the origin. And the reasoning of that is the following. If you want to take any equation and you want to shift it, you want to shift the origin to, say, the point hk. Well, then what you do is you subtract h from the x and k from the y. And so there's your ellipse that's been shifted so that the center is at the point hk instead of the origin. And that's exactly what we're seeing down here after we completed the square. All right, so we'll definitely be practicing completing the square on some future exercises in this section and also in the rest of the sections of Chapter 10 dealing with conic sections. Okay? All right, let's take a look at problem number 12 now. For the following exercises, write the equation of the ellipse in standard form, identify the endpoints of the major and the minor axes as well as the foci, meaning give the positions of the focal points and all of the ends of the ellipse along the axes. So x squared over 100 plus y squared over 64 is 1. The only thing I would suggest to rewrite this is to realize 100 is 10 squared and 64 is 8 squared, and you have the standard form. Looking at this, the larger denominator is under the x, so the major axis is in the x direction. Okay? The endpoints of that major axis are easy to find. Think about it. You have this ellipse, and you want to know where this and this are on the x-axis. Well, these are points where y is 0, so simply come to the equation and put 0 in for y. That wipes out that term. And so you get x squared over 10 squared is 1, which means x is either 10 or x is negative 10. The minor axis endpoints. Those are the y coordinate points. Knock out the x. Y squared over 8 squared is 1. So y is either 8 or y is negative 8. Those are your minor axis endpoints. And your focal points. Well, remember, the focal points are going to be plus or minus c0, where c squared is a squared minus b squared. That was the substitution that we did in our derivation. Let b squared replace a squared minus c squared means c squared is a squared minus b squared. And c squared, c is referring to the location of the focal points. Okay? All right. So that means c squared is 100 minus 64, or 36, so c is plus or minus 6. Okay? And there you've solved the problem. Let's take a look at number 14. In 14, we're given 4x squared plus 16y squared is 1. To get this into standard form, I want to write this equal to 1 like it is, but I want to have these numbers in the denominator. This is how you can do that. Just flip them. So you get x squared over 1/2 squared plus y squared over 1/4 squared is 1. Again, the x squared denominator is the larger one. So the major axis endpoints are going to come from here. When the y is 0, x is either going to be a half or negative a half. Your short axis is the one with the smaller denominator. When the x is 0, y is either a fourth or negative a fourth. C squared is a squared minus b squared. That is a fourth minus a 16th. So that's 4/16 minus 1/16, that's 3/16. So C is plus or minus root 3 over 4. And that's along the x-axis, which is the long major axis. So your focal points, plus or minus root 3 over 4, 0. All right, let's take a look at problem number 18. We have x minus 7 squared over 49 plus y minus 7 squared over 49 equals 1. Notice the two denominators are exactly the same. As I mentioned earlier, when your two denominators are exactly the same, your focal points, remember c squared is a squared minus b squared, c is going to be 0. Your focal points shrink down to being 0 distance away from the center. Your two focal points have shrunk down into being one focal point. That is because this is indeed a circle. Okay, the center of the circle is 7, 7. There is no major and minor axis. They're both the same length. Okay? And they are 7 units away from the center. So that means the endpoints, you get 7 plus or minus 7 comma 7, and then you get 7 comma 7 plus or minus 7. The 4 endpoints of these two axes are these 4 points. The focal point, there's only one, and that is the origin, because your distance from the origin to the focal points, your value c is 0. And so there's your information for an 18, kind of a degenerate case of an ellipse, right? It just evolved into a circle instead. All right, let's see if we can recycle some of this paper and save some. Let's take a look at number 20. We have 9x squared minus 54x plus 9y squared minus 54y plus 81 equals 0. I have to complete the square on this. So put your x's together and take out the coefficient of the x squared. And we'll leave space to add a term in there. Same with the y's. Take the coefficient of the y squared out and leave a space. All right, now coming in to complete the square. Take this negative 6, divide it by 2, you get a negative 3, and you square it, you got a 9. Same thing here, negative 6 divided by 2 squared is 9. I had to put 9 in the parentheses in order to turn this into a perfect square, and this in the parentheses to a perfect square. But when I added 9 here, I didn't add 9 to the left, I added 9 times 9, or 81. Same thing here. When I added 9 here, I added 9 times 9, or 81. So I have to add that to the right-hand side to balance it. Now you'll notice you have an 81 on the left. You can cancel that with one of the 81s on the right, and that leaves just this 81 on the right-hand side. If I divide everything by 81 to get everything equal to 1, I get this, and when we cancel, I get the standard form. And once again, the x and the a and the b values are the same. A squared and b squared are both 9, so this is in fact a circle. The center is 3, 3, and the radius is this denominator's square root. So r squared is 9, means the radius is 3. And there's your circle. Alright, let's try one more with these, completing the squares that does not devolve into a circle. Let's take a look at 26. 9x squared plus 72x plus 16y squared plus 16y plus 4 is equal to 0. So take the 9 out of the x's. Take the 16 out of the y's. And now let's see what we have to add. 8 divided by 2 is 4. Square that, you get 16. 9 times 16 is 144 that we've added to both sides. Take this 1, divide it by 2 and square it, you get 1. 16 times 1 is 16. So I've added 144 here and 16 here when I added the 16 and then the 1 inside here. Alright, now these are perfect squares. That's 9 times x plus 4 quantity squared. This is 16 times y plus 1 quantity squared. When we subtract 4 from both sides, let's see, 156, right? $24, $26. I would have to divide everything by 156, and I'm sure the author made a little arithmetic error here. I think he had hoped this would come out to be 144, which it would have if he had had the correct number here. All right, you know what he would have to have here is a 16 instead of a 4, so that would cancel that and give you 144. Okay, that's what he intended to do. He just made an arithmetic error when he wrote the problem. Okay, so let's go ahead and fix the problem for the author. We don't want to have 4 here. We want to have 16. That way this will cancel with this, and we get 144 on the left. And that means we can divide everything by 144. And you can see why that's preferred. 9 and 144, that leaves a 16 in the denominator. 16 and 144 cancel. Leaves a 9 in the denominator, and there's our 1. Okay? Alright, now the center of this, x minus h, y minus k, the center, therefore, is -4, -1. The long axis is the x direction because this is the larger of the two. So that means we have to go out 4 to the left and to the right of the center. The endpoints. You want to go out left and right 4 from in the x direction. The minor axis, you want to go up and down 3. So up and down is on that -1. And the focal points. Well, c squared is 16 minus 9 is 7. So c is plus or minus the square root of 7. That's how much you want to move to get to the focal points from the center. And those are in the x direction. So -4 plus or minus root 7, -1 would be the location of your focal points. All right. Let's jump down to problem number 38. We want to graph the ellipse. And here we're given x squared over 2 plus y plus 1 squared over 5 equals 1. Okay, we want to note where the center of the ellipse is. We want to note where the vertices are, meaning the endpoints of the major and the minor axes. And we want to note the location of the focal points for this ellipse. So let's start by finding, of course, the center. That's x minus 0, so h is 0. Y minus a -1. 0, -1 is the center of this ellipse. The long axis is in the y direction. The minor axis is in the x direction, 0 plus or minus the square root of 2. And the focal points. C squared is the larger minus the smaller. C squared is 3, so you're going to get C is plus or minus root 3. And you're going to move in the y direction from the center, plus or minus root 3. For your focal points. Okay? Alright, so let's see if we can graph this thing. Here's my x-axis. Here's my y-axis. The center of this thing is 0, -1. There's the center. Okay? Our major axis is in the y direction. We go up root 5, and we go down root 5. And our minor axis is in the x direction. We go to the left and the right root 2. Okay, and our focal points are on the y-axis. And these are the locations of all those things for that graph. Okay, we have to give the actual location of the points and the graph. And there we're done with the problem. All right, let's take a look at number 42. We're given 64x squared plus 128x plus 9y squared minus 72y minus 368 is 0. All right, so for the x's, take out 64. That's x squared plus 2x plus, let's go ahead and complete the square. Half of 2 is 1, square that. Take out the 9 from the y. And let's go ahead and complete the square. -8 divided by 2 is -4, squared is 16. And let's see how much did we add. 64 times 1 and 9 times 16. All right. So 64, this is x plus 1 quantity squared plus 9 y minus 4 quantity squared. And we have 64, 144, and let's add the 368 to that. So 144 plus the 64 plus the 368. And that gives me 576. Now, if I divide everything by 576, I'll get the 1 that I need on the right-hand side. 576 divided by 64 is 9. That means that 576 divided by 9 is 64. And there's our standard form. Looking at this, we can see the center is -1, 4. That the major axis goes in the y direction, so that means we're going to go up and down from 4, 8. And the minor axis is in the x direction. That's the smaller of the denominators. We're going to go up and down 3, or left and right 3, sorry, from this point. So -1 plus or minus 3. And the focal points, they'll be in the long direction. C squared is 64 minus 9, which is 55, so C is plus or minus the square root of 55. Go from 4 up and down root 55 to get to the focal points. Alright, so what does this thing look like when we graph it? Again, our center, -1, 4. The major axis, we're going to go up 8, down 8. We're going to go right and left 3. And it's going to look like this shape here. And the focal points, root 55. So 55 square rooted gives me about 7.5. So almost all the way up to here and down to here for the focal points. And we've got the graph. All right, let's try in problem number 48 to figure out what our ellipse looks like. In 48, what they tell us is, for the following exercise, use the given information about the graph of each ellipse to determine its equation. Okay, so in 48 they say the center is at the origin. That's great. It's just going to be an x squared and a y squared. Symmetric with respect to both the x and the y axes, with a focus at 3, 0. So there's a focal point. And the major axis is twice as long as the minor axis. Okay, so if that's a focal point and we have symmetry, there's another focal point here. So we know c squared is 9, right? C is 3 or -3. I'm looking for this form, right? All right, so I know that A, the distance along the major axis, is twice the distance along the minor axis. A is twice B. And I know that A squared minus B squared is C squared. So let's see what I can fit in here. If A is twice B, 2B squared minus B squared, and C is squared is 9, then I have this equation to solve. 4B squared minus B squared is 9, 3B squared is 9, B squared is 3. Now I know what B squared is. What is A? Twice B. Done. There's the equation. So that wasn't terribly difficult, actually. All right, let's take a look at number 50 and see if we can get this one. They tell us the center is the point 3, 5. So I know I'm going to have x minus 3 squared over a squared plus y minus 5 squared over b squared equals 1 so far. Okay, they tell me that the vertex is 3, 11. and focal point. 5 plus 4 root 2. Okay, so the focal point is moving not the x-coordinate but the y-coordinate. So that means in this case b squared is bigger than a squared for sure. And let's see. That means, oh, and the center was 3, 5, so that means we moved from the center to the vertex from 5 to 11, and we moved 6. So b is 6 or negative 6, right? All right. Now to find that smaller a. I know that from 5, I moved to 5 plus 4 root 2. So c is 4 root 2, meaning c squared is 16 times 2, or 32. And I know that c squared is b squared minus a squared. So 32 is the b squared, which is 36, minus a squared means a squared is 4. And I've got that figured out now. And there's the equation of that ellipse. All right, let's take a look at, skipping down, problem number 58. In 58, they give you x plus 6 squared over 16 plus y minus 6 squared over 36 is 1. In other words, this is x plus 6 squared over 4 squared plus y minus 6 squared over 6 squared is 1. They ask you, what's the area of this ellipse? Well, the area is the a and the b times pi. 4 and 6 can serve as your a and your b. So you're done. That's all you have to do for that. All right, let's take a look at one last problem. Number 64. In 64, we're trying to find a height on an ellipse. So they tell you the arch has the shape of a semi-ellipse, the top half of an ellipse, in other words. The arch has a height of 8 feet and the span of 20 feet. Okay? In other words, you're spanning 20 feet in this direction. So from the center, you're going out 10 and negative 10, and you have a height up to the arch of 8 feet. And there's your ellipse, okay? So envision this as the x-axis and the y-axis going through the origin, and this height here is 8. Okay, and these are the points 10, 0, and negative 10, 0. Now we want to find the equation of this ellipse. Well, the major axis is the x-axis, the minor axis is the y-axis, and you're centered at the origin, so it's very easy to come up with this. Equation of the ellipse, right? Very, very simple. Okay? And now the question that you're being asked is, if we were to go, let's see, 4 feet from the center, 4 feet over, which may be about here, what would be this height? In other words, what's the y value there? Well, all you're really doing there is plugging 4 in for x and solving for y. So 16 over 100 plus y squared over 64 is 1. You subtract 16 over 100 from both sides. That leaves 1 minus 16 over 100 is 84 over 100. And then you multiply both sides by 64. To find y, you take the square root. Square root of 64, 8, square root of 100, 10, square root of 84, well that's not a simple number, but we can certainly calculate that out. 84 square rooted is about 9.17. You multiply that by 8 and divide by 10, and you get 7.33 feet. That is the height, which makes sense. It was 8 feet here. It's dropped down in height a bit over here. And there you have it. That's how we work with our ellipse equations. I'm sure you may want to go through this a few times, slow the video down maybe, rewind it a few times, make sure you understand what is being done when we go through these steps. It's a lot of arithmetic to go through. The arithmetic is not difficult, but there's a lot of it to go through. Okay? As always, good luck on your homework. If you have any questions or concerns, do not hesitate to contact me. I'll be happy to help you.